microphone is on. Listen, I'm delighted to be here in Kazakhstan, where Baikonur is located, someplace I've been wanting to visit for many years. Before I start, I want to ask you, how many of you have been to Baikonur? Have any of you been to Baikonur? We have a few people here, there. Has anybody here seen a rocket launch? None of you have seen it. You've seen it. We have one person who's seen a rocket launch. Well, that's great. Good for you. Well, Baikonur, if I can get this right. So Baikonur is the largest spaceport and the largest launch center on the planet. There's other places on the planet that launch rockets. There's Cape Canaveral in Florida, which is very good with its own publicity. But Baikonur is the oldest cosmodrome, and it's the largest cosmodrome, and it's a cosmodrome where very exciting things are happening now and will continue to happen. Baikonur is where the first satellite ever was launched in 1957. Baikonur is where the first manned space flight took place in 1961, and also the first space station was launched from Baikonur. So Baikonur is absolutely on the cutting edge of the space industry, and it has been from the very beginning, literally from the very beginning. And now Baikonur is the only launch facility on the planet that you can launch people from, the only place where we do human spaceflight from. And these are some of the famous R-7 rockets that were designed, which I'll talk about later. So this talk is about the unique experiences of Kazakhstan and Baikonur. It's about what brought us here today in the space industry, and also very much about the technology that allowed us to be journalists. The technology that Omar was talking about this morning is only possible because of satellite technology. So much of what we're doing, and in fact, all of you that are taking pictures right now with your iPhones, you're only able to do much of the work because of satellite technology, because of space technology. So it's very relevant to all of the things that we do in our everyday life. But before we start talking about the details of that, I'd like to take you on a little journey. I'd like to take you on a little journey to set the scene. This is the International Space Station. The International Space Station has been in orbit since 1998, and it has had continuous human habitation since the year 2000. Now, it's just up here, 400 kilometers up here, which isn't really very far. Space isn't very far from where we stand right now. If we could just drive our cars straight up to it, it would only take 2 hours in our car. My car won't, no matter how often I ask. And International Space Station has had is one of it may be the most exciting science experiment on the planet, and the most international. Since 2000, you've had 236 cosmonauts and astronauts on the International Space Station from 18 different countries. Now, if you want to know the difference between what a cosmonaut and an astronaut is, well, they're actually the same thing. Both of these words come from Greek. Cosmonaut means universe sailor. Astronaut means star sailor. So I want you to pick one of those titles, one of those enviable job titles, settle into that role, because we're going to go on a little trip right now. So welcome to the International Space Station, the ISS. Now, like all of the many people that have lived there, men and women, you've just finishing a 6-month stint on the ISS, and today is your last day, and you're getting ready to depart. You've been orbiting the Earth in a tin can, a series of tin cans, at 28,000 kilometers an hour. So that means that you're going around the Earth every 92 minutes, orbit around the Earth every 92 minutes. You're in the sunshine for 45 minutes. You're in the darkness for 45 minutes. So before you go, you want to say goodbye to the ISS, which is the size, with the solar arrays, the size of a football field. So I think that you should do a little float through the ISS to see all the bits of it. Can we bring the audience up?
Jackie, what are you doing down there?
Crashing things.
This is one of the cool things about space, too.
Ground control. Please bring the audio just all the way down. Okay, so this is one of the American astronauts doing a float through and showing you a little bit about it. But it's a series of modules. There's a research center, there's laboratories where thousands of experiments have happened. There's the living quarters, there are the sleeping quarters, and there's also exercise area, because you are going to be doing 2 hours of exercise every day that you have been over the last 6 months on the ISS. So you're going to float through and say goodbye to these places that you've been living at for the last 6 months. And you don't want to forget a visit to the cupola. Now, the cupola was especially designed with its 7 windows to give a very good view of the planet. It is the best view, without doubt, that you can have of Earth without donning a spacesuit. And the 7 windows are there for a number of purposes. They're to monitor the docking of spacecraft when new astronauts and cosmonauts are arriving, when supply ships are arriving. They're for Earth observation, and they're also for your pleasure, because in the few hours that you have every day that you're not doing experiments, that you're not doing broadcasting, educational outreach, that you're not preparing your meals, that you're not doing your exercise, a lot of people like to take their music, put their headphones on, and have a look at the world as it goes under them at 28,000 kilometers an hour. So drink in this spectacular view, because it's the last time you're going to have it, and it's your last few hours of living in zero gravity. This is the kind of thing that you have seen when you're in orbit. From the cupola up there. At night, you can see the city is lit up. You can look down and you can see the eye of a storm when there's a hurricane. You don't see any borders up there. It's just one Earth. There's the city, it's all lit up at night. The view from the cupola. Ground control, can you bring the audio down? If you ever want a break from your everyday life, go on to the European Space Agency website, Roscosmos website, NASA website, and watch some of these amazing videos. They will chill you out and I think inspire you too. So, 2 of your crewmates are also getting ready to come back to Earth with you as you leave the International Space Station, because the Soyuz rocket, which is the only rocket, the Soyuz capsule, which is the only capsule that takes you up to the International Space Station and down from it, is designed for 3 people. And you're going to crawl into these spacesuits. This is Paolo Nesboli, who I was lucky enough to spend some time with in Italy at the European Space Agency. These are the spacesuits that you're going to crawl into. They're called Sokol spacesuits, which I don't have to tell you means falcons. So crawl into your Sokol spacesuit and seal your air seal very tightly, because that will protect you from any decompression accident. So you'll remember that. And you're going to then get into your Soyuz capsule, which is a dock to the side of the International Space Station, and strap in tight. You have a 5-point strap and restraint. You're going to be plunging down 400 kilometers to Kazakhstan. Now, the thing is, you know, as a cosmonaut, you know that the Earth's atmosphere is designed to protect the Earth. Now, that's a good thing, because things coming into the Earth's atmosphere burn up, whether it's a meteorite or a bit of space junk. They burn up and they don't bother us. We get hit occasionally by meteorites. In fact, quite a few meteorites, but they're quite small. But the problem is, you don't want to get burned up either. So you have a heat shield which is going to protect you and keep you keep you alive, because when you re-enter Earth's atmosphere, you are going to be hitting temperatures of up to 2,000 centigrade. Now, 2,000 centigrade is hotter than you need to melt bronze. It's hotter than you need to melt aluminium, to melt silver and gold. But don't worry, the heat shield does work. So the three of you are settled in the Soyuz spacecraft, and you gently push away from the International Space Station. You'll do a few orbits around Earth first, and it's going to be your very last chance to see light for 45 minutes and then night for 45 minutes. And then you're going to enter the Earth's atmosphere at just the right angle and speed, at the optimal descent trajectory. Now, this has to be calculated very carefully, because if you hit it too steeply, you're going to be going too fast, and then your heat shield might not be enough. If you hit in a shallow way, you might bounce off the atmosphere, literally like throwing a pebble over a pond, and skip off the atmosphere and go further into space. You don't want to do that. But don't worry, you've got it right. So when you reach just the correct point, ground control will tell you to hit your rocket burn, and you do for 4.5 minutes. Your braking engines fire, and now your roller coaster experience is about to start. Now, this is the part that cosmonauts and astronauts either love or hate, because it's a rodeo ride, it's a fast, bumpy ride down, and you're going pretty much straight down. So brace yourself. You've started to crash for the atmosphere now, and you know that you're leaving space because you're feeling something you haven't felt for 6 months, which is gravity. Now, gravity, living away from gravity, has done all kinds of things to your body. You're probably 2 centimeters taller than you were before you started this journey 6 months earlier. And your blood supply has gone throughout your whole body instead of just concentrating on one part of your body. So your physiology has changed. So you're going to feel gravity. And as you're sitting there in your seat, in your Soyuz seat, which is molded to your body, each person has had a mold of their body taken, you're going to start feeling, first your legs feel heavy, then your arms feel heavy, then you feel pressed against your seat. Gravity is starting to really hit. Not only gravity, but G-forces. G-forces are the gravitational force. Now, the speed that you're coming down at is so fast that your body will hit 4 Gs. That means that your body feels 4 times heavier than it is through gravitational force from the speed of your descent. Breathing gets harder. You can even feel the weight of your watch that you're wearing. So the next step is to jettison the parts of the Soyuz capsule you don't need. Now, this is the capsule that you launched from Baikonur in, and you docked at the International Space Station. And this is what you've gotten into to come back down. You can get rid of the instrument compartment on that side. You can get rid of the utility compartment on this side. You don't need them, and they decouple. You're right in the middle, and you'll see them shoot past the window, the little windows in the Soyuz. Now you're starting to feel hot now, even through your spacesuit. You can feel the heat. And suddenly it becomes even more intense. And outside of the window of your Soyuz, all you're seeing is flames going past. You feel like you are in a furnace, and you are, and you're going faster than the speed of sound. But all of a sudden, there's an enormous jolt, and you start pitching and rolling and bouncing because your first parachute has opened. This is a good sign. If you have lived long enough for your parachute, and don't worry, you will, I promise you. I wouldn't take you on this trip unless you could come back safely. The parachute is open. The first parachute is opened, and you are 10 kilometers above the Earth. Now, you're still going very, very fast. You're still going 800 kilometers an hour. And as the next few parachutes open, the second parachute will open at 8 kilometers above the ground, and that slows you down to a mere 22 kilometers an hour. That's still pretty fast. So you're heading down.
Есть запись.
That's what it's going to feel like. And ground control has seen you. You can hear them counting you down. And they're saying, Otkroi rot. Keep your mouth open. You don't want to have your mouth closed when you hit the ground. You might bite your tongue off. So that's a good reminder. So you've landed, and it's silent all of a sudden. The rescue team, you know, has spotted you because you've heard them counting you down. They've told you we're almost there. But it's silence for the first time in 6 months, for the first time on this little 3-hour journey that you've spent. It's silence. But then you hear a new sound, and that somebody is undoing the hatch, and all of a sudden you're having the air of Earth again. And what's it smell like? Well, I'll tell you what astronauts and cosmonauts have said it smells like. The air smells like honeysuckle. The air smells like warm grass. The air smells like sunshine. And I promise you, after your 6 months in zero gravity on the International Space Station, you'll never take the Earth for granted before. You'll never take rain for granted, wind for granted, and just the air you breathe. Now, this is I deliberately chose an astronaut who I was able to spend some time with. This is Samantha Cecchi, an Italian astronaut who was a fighter pilot in the Italian Air Force and is also a scientist and a linguist. Remarkable person. And the effects of gravity, for her, it took her about 6 months to get used to gravity, but she's enormously happy. Samantha's also the first cosmonaut or astronaut to get an espresso machine put on the International Space Station. And there she is. Now, as much as I enjoyed landing in Almaty International Airport yesterday, I would trade that any day to arrive in Kazakhstan like that. Anybody want to join me? Okay. So how many people have landed in Kazakhstan this way? Well, it's about 150, which is more than a quarter of all the people that have gone into outer space. And all of those people launch from Baikonur as well. So the total number of people that have been into space is, I think, 548. Now, what's exciting is that on June 3rd, that's the Sunday after this one, 3 more cosmonauts and astronauts will land in Kazakhstan. They'll be coming down from there 6 months. There's a Russian, a Japanese, and an American. So, and then a week after that, 3 more cosmonauts and astronauts will launch from Baikonur. There's always 6 people on the International Space Station. So for about a week, those 3 will be a bit lonely. They'll find the International Space Station a bit roomier. So why does all this matter to us? What's so important about this? Well, there's a lot of answers to that. First of all, the International Space Station is an astonishing orbiting science experiment. And there's groundbreaking developments that have happened there, not only in terms of the communications that we use, but in terms of science, human health, space health, manufacturing. They're doing manufacturing experiments, how you make ball bearings in zero gravity. Earth observations from space are a very, very important thing to all of us. Vaccine has been developed in space. Images and data that we're using for disaster relief, whether it's hurricanes or refugee movements, farming. So all of this has a tremendous impact on our lives, and we've grown up with this. The people in this room, we are the generation that has grown up with this remarkable technology. So we're going to talk a bit more about that and how it relates to journalism. But first, I just want to take you back a little ways to talk about how it all started, to put it all in context, something that journalists have to do. Now, communication satellites were only developed following the first launch of the Sputnik in 1957 from Baikonur. Television images only began to transmit after satellites were developed to the point that they could do this in the early 1960s. Not to mention the computers that we're all using. Okay, computer miniaturization were only developed so they would be small enough to put in spacecraft, in satellites and all that. The cameras that we're all using, and you're using right now, were miniaturized in order to be used on spy satellites. So we are the beneficiaries of all of this as journalists. Now, let's mark that change that technology gave, that allowed us to broadcast breaking news 24 hours a day, that allowed us to be chased by our news desks all night long, that allows certain people to tweet at 3 in the morning. But how did we get to this point? Well, let me take you back to 1955. When we were back in the analog age. Now, journalists use typewriters. Anybody here ever written on a typewriter? Okay, I know a few people. Okay, there's a half a dozen of you that can work with a typewriter. Making phone calls using landlines and undersea cables, radio transmitters. If it wasn't for the satellite, the space revolution, we would have newsrooms like that. They didn't work very hard, but they were all men, weren't they? I love this image. But in 1955, about the time this photograph was taken, no, actually, that was a bit earlier than 55, looking at the telephones, something happened that was very unexpected, ordinary and unexpected. So let me give you a tale of the unexpected. International Geophysical Year. Okay, now this is something that happened every 50 years. It dated back to the 19th century. It happened every 50 years for scientists. And in 1957, it was going to be a 50-year anniversary. They declared another International Geophysical Year. Now, this is all very exciting if you were into oceanography, seismology, meteorology, but it wasn't exactly front-page news. And so the press release wasn't much noticed outside the scientific community. But in America, where President Eisenhower was in the White House, his press secretary gave a statement which said, I'll read you what it says. The United States is going to launch this is a quote, small Earth-circling satellite to mark the International Geophysical Year. You notice the word Earth-circling. The term orbit wasn't even in popular use then. Now, this press release was, like I say, important to academics, important to some researchers, but no one else really paid much attention, except a few people that are the people who make our story, particularly Sergei Korolev. Now, Sergei Korolev, who was called the chief designer, that was the only name he was known by until after his death, was an extraordinary Russian who changed so much of our lives. And he also drove the Soviet space industry. Now, Korolev, after being a very promising flight designer, was caught in Stalin's purges. Really through the jealousy of another colleague, he was thrown into a Siberian prison camp in the 1930s. And it's a miracle that he survived, because so many people didn't. When the Second War broke out, he was let go to help flight development and jet rocket development. And he survived and went on to be the person, among others, that the Soviet Union sent into Germany at the end of the Second War. Because what was happening there is they had developed the V2 rocket. That was one of the Nazi revenge weapon, the V2. Now the V2 was a very large bomb. And it was launched towards the end of the war. It killed thousands of people in Britain and in Belgium. It probably killed even more people than that in the slave labor camps where it was built. But it was built by somebody called Wernher von Braun. Now, Wernher von Braun, when Sergei Korolev heard this press release about a small Earth-circling satellite, he knew who was probably behind it. He had been sent into Germany at the Second War to urge von Braun to come over and come to the Soviet Union. Von Braun knew this was about to happen. The war was ending as a catastrophe for the Nazis. He, with his 100 top scientists, went and surrendered to the Americans. Now, this is von Braun with a spectacularly broken arm, which had nothing to do with anything other than some bad driving. So von Braun is in America, behind the small Earthling satellite, and Korolev is in the Soviet Union. So when this was announced, and only a few hundred people in the whole world knew what a satellite was, Korolev sees this as an opportunity to push forward the program that he had for launching a satellite, because he had been building intercontinental missiles. So he went to the Kremlin and he said, the Americans seem to be at a very advanced stage of development with satellites. Can you please give me some more money and let me do this? Khrushchev didn't really understand what he was asking, but he said, fine, go ahead and launch the satellite. Just don't let it interfere with the rocket technology, which could carry a nuclear missile. So using the R-7 rocket, which is still in use today, it's just gotten bigger and better. Korolev and his team had developed this. They go to Baikonur and they launch this satellite, which is Sputnik, the first satellite. And this is the noise that it made. Thanks. Now, the starting pistol had been fired. This is the beginning of what became known as the space race. The Sputnik electrified the world. It terrified the Americans. And Moscow then released this photograph of Sputnik. And people could watch its trajectories across the night sky, and they could tune in on their little radio headsets and hear the telemetry. Nothing man-made had orbited the Earth before. This was just revolutionary. And an international frenzy was created. Now, after the successful launch, Khrushchev was moderately pleased, and Korolev was moderately pleased. And it took several days. This is the world before social media, before they realized the impact of this. And the impact was enormous. The New York Times said the launch had been a major global propaganda and prestige triumph for communism. The science fiction writer Arthur C. Clarke commented, the day Sputnik orbited the Earth, the U.S. became a second-rate power. It became a symbol of American weakness. But others took the longer view. Now, this is a lovely quote that I found from an Australian newspaper. The conquest of space has begun. The great dream men has moved from the realm of futuristic fiction to tentative reality. The 4th of October, 1957, should be celebrated as one of the most important dates in human history. I would agree with that. So, Khrushchev realizes this is a spectacular propaganda triumph. So he calls in Korolev and he says, I want more. Korolev cancels all leave, and for the next 4 weeks, he and his team don't sleep. 4 weeks later, they're back at Baikonur. And they're going to launch Sputnik 2. It is substantially bigger, and it carries a passenger, a little canine cosmonaut, Lika. I think you all remember this photograph. Now, Lika, like every single dog that was used in the space program, was a stray that was found on the streets of Moscow. They thought, well, she must be pretty tough if she survived the streets of Moscow. And she won her place by the ability to sit still for a long time. Now, they hadn't perfected re-entry, so the team knew that Lika was on a one-way ticket. So the night before, one of the scientists took Lika home to his children to play, so she could play with his children the night before. He said, I wanted to give her a little happiness. So Lika is launched, and her flight catches the imagination of the world. And the outrage of animal lovers. Now, If you know anything about Britain, you'll know that we are a nation of animal lovers. So this is from a British newspaper. The world asks how to get her down, the red Sputnik. So the British press in particular were more outraged about Lika being up in space than praising the scientific achievement. And Lika did die from overheating in a few hours, but the subsequent Soviet space dogs survived, and in fact, some of them would be adopted by the scientists when they came down. Some of them had puppies that were given as diplomatic gifts around the world, and one of them, Strelka, had a puppy called Pushkina, which was given to Jacqueline Kennedy. So a Soviet space dog was raised in the White House. So meanwhile, the Americans had a series of really abject and very public failures. They had one rocket after another one blowing up on the launch pad, and all of their launches were broadcast live. Finally, it started happening, and Eisenhower signed an act creating NASA, which is still going strong. They wanted to catch up and surpass the Soviet Union, but it was going to take some time. Meanwhile, a 26-year-old pilot called Yuri Gagarin was undergoing a series of tests. He was undergoing tough medicals, isolation chambers. He was G-force experiments and acing them. And although there was other pilots that were just as skilled, Gagarin had what Khrushchev called a winning smile and a proper peasant background. He was still smiling on the 12th of April, 1961, when he shouted, "Let's go," and his rocket took off. Now, for 108 minutes, he saw a sight that nobody had ever seen before. For 108 minutes, he was the first man to look down and see the Earth from space, to see the curvature of the Earth. He left the Earth. He wasn't allowed to. It was very secret. He wasn't allowed to tell his parents what was happening, that he was even training to be a cosmonaut. But he talked to his parents before this trip, and he said, "I'm going on a business trip." And they said, "Where?" And he goes, "Oh, it's far." And they said, "How far?" He went, "Very far." He was launched as a second lieutenant, and he was promoted to major while he was in space. So when he landed, and his father, who was at work, and the radio was on, everybody heard about this launch, heard that a Major Gagarin had landed in a space capsule. He thought, that's a coincidence. Same name. So 4 weeks after Gagarin circled the Earth, the Americans finally get somebody up, Alan Shepard. But it was just suborbital. It was a 15-minute hop up and a 15-minute hop down. He just landed in the sea 500 miles from Cape Canaveral, where he was launched. But it cheered up Americans enormously. And the chief of NASA, a guy called James Webb, used this feel-good factor to go to President Kennedy, Kennedy was now in the White House, and put forward to him probably something that was one of the most audacious plans that has ever happened. He said to Kennedy, "We may not be able to win on short-term goals, but we can win on long-term goals." And he gave him an idea. And it's quite fitting that the big telescope that's being launched the year after next is called the James Webb Telescope. So Kennedy gave this speech.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
Okay, so Kennedy says, we choose to go to the moon, not because it's easy, but because it's difficult. I can't imagine an American politician saying that at the moment. But he also said something, a second part of it, which is worth remembering. He says, we have vowed that we will not see space filled with weapons of mass destruction, but with instruments of knowledge and understanding. So We should remember that part very much. And that's, to me, is what the International Space Station and much of this we're going to be talking about is about. So meanwhile, Korolev launches a series of rockets with his R-7 engine. He launches the first manned space flight lasting a full day, the first simultaneous launch of 2 Vostok capsules, the first multi-day mission, which is 2 hours short of 5 days. That's a long time. And these are tiny little capsules, the Vostok and then the Voskhod. So it was one stunning coup after another, and it was all launched from Baikonur. But the United States had started catching up, and in 1962, John Glenn, who became one of the iconic names in the American space program, finally went into orbit on Friendship 7. John Glenn actually, later on, who died a couple of years ago, but in his 60s, he went on, in his late 60s, he became an astronaut on the International Space Station. But Korolev's team still had quite a few surprises up their sleeves. In 1963, they launched Valentina Tereshkova into space. Now, Valentina Tereshkova is 23 years old. She was a textile worker, but a parachuting champion. And she dreamt of space. Now, the parachute was very significant. She needed to be able to parachute to come down in the last stage, because that's what they did. But she became a pioneer, and I've been lucky enough to meet her. She's still working for women's rights. She's a remarkable character, and very feisty and very tough and very fit. It took the Americans 20 more years before they put a woman in space, which was Sally Ride on the space shuttle. Then another high point for spaceflight happened in 1965 when one of my heroes, a cosmonaut named Alexei Leonov, became the first person to perform a spacewalk. Oops, there's Valentina. Sorry, I've skipped Valentina. This is the first spacewalk ever.
Это подлинные документальные кадры. Они сняты 18 марта 1965 года автоматической кинокамерой, установленной на борту космического корабля «Восход-2». Пилотирует корабль Павел Беляев. Вышел из корабля Алексей Леонов. Человек в межпланетном пространстве. И он живет, работает, улыбается. Значит, люди смогут стыковать корабли, монтировать орбитальные станции, пересаживаться с ракеты на ракету, выходить из аварийных ситуаций. Смелый и важный шаг совершен по пути к Луне.
Well, I was lucky enough to meet Alexei Leonov in London at the Science Museum a couple of times. And he's still going strong. He's in his 80s now. He was a bit unwell last year, but I hope he carries on for a long time. He's a very inspirational man. He said how insignificant he felt. He said, like a tiny ant compared to the immensity of the universe. At the same time, I felt enormously powerful. I felt the power of the human intellect that had placed me there. Now, his exhilaration only lasted about 10 minutes before he realized that something major was going wrong. His spacesuit had started inflating from the pressure, and he was so inflated that his hands slipped out of the gloves, his feet slipped out of the boots. His spacesuit, the pressure was increasing, and he was too large to get back into the capsule. So he was live on the radio at the time, so he couldn't say Roscosmos. Well, it wasn't Roscosmos then. He couldn't say Baikonur, I have a problem. So he had to figure out how to make his spacesuit deflate to get back in. So he took a high-risk strategy, and there was a valve on his sleeve that could let out oxygen. So he thought, I have no choice but to do this. And that, even then, was very difficult because his hands had slipped out of the gloves. So he turned this valve, and of course, there was a distinct possibility that he would lose all of his oxygen, but he knew for sure that he would not get back in. So he started letting this out, and deflated to the point he could slip back in. to the capsule. But the problems weren't over then, because they lost their automatic guidance system. And they lost contact with Earth too. Because in those days, because we didn't have the communication satellites, there was long periods when cosmonauts and astronauts were in flight that they couldn't contact Earth. So they lost their automatic guidance system, so they had to work out mathematically what the trajectory of re-entry was going to be. And they saw that they were going to overshoot their landing in Kazakhstan. But they didn't want to overshoot it to the extent they landed in China, because relations weren't very good then. So he chose Siberia, which is where he and Pavel Belyaev, the other cosmonaut, had come from. So remember, the computing power on board then was completely insignificant. And they knew that if you hit the atmosphere in too shallow an angle, you'd bounce back off. If you hit it too steeply, you would have a big problem in terms of heat. So they got it right, and they landed. But they didn't have that big bang when they landed. It was much softer than they expected. And they discovered why. They'd landed deep in the taiga, in the Siberian forest, and they'd landed on meters and meters of snow, which then rapidly melted. When they popped open the hatch, they couldn't open it because they had fallen against birch trees. So they had to rock the spacecraft back and forth. They open it up. There they are in the middle of this forest. And it's winter, and it's about to be night. So here's Leonov again. We'd landed in the natural habitat of bears and wolves. And it was spring, the mating system, when all these animals are at their most aggressive. We only had one pistol aboard our spacecraft, a firearm I'd stowed away at the last moment, but we had plenty of ammunition. Now, I love this, that this is a fact that a cosmonaut can stow away his own pistol and a lot of ammunition. You couldn't do that on board a spacecraft nowadays. But it was a good thing they had that. So they had a terrible night that night. The temperatures plummeted to 30 centigrades below. And they only had one way of contacting anyone, which was Morse code. Morse code. So they tap out a message saying, here we are, we're somewhere in Siberia. Now, the only people that picked this up were a monitoring station in West Germany. They told Moscow, Moscow told Korolev's team, and they headed out and tried to find them. Now, the next morning, they open up their hatch and they come out, and they hear a helicopter overhead, and they hear voices. They've had to ski in because there was nowhere to land. The forest is so thick, the helicopter had nowhere to land. But their rescuers had skied in. And the helicopter came overhead. Now, Leonov told me that realizing they didn't have the right gear, they dropped them nice big jackets, and they dropped them big trousers. The trousers got caught on the tree, he said. He said that didn't matter. He said, but what broke his heart, he said he almost felt like bursting into tears, was the bottle of vodka they threw down broke. So they built a shelter while trees were cut down 10 kilometers away for a helicopter to have space to land the next day. And at the end of this remarkable adventure, they ski out. So the first man who walks in space is only rescued because of using technology of skis and the 19th century communication of Morse code. Leonov is an artist, and so he's done many paintings of his spacewalk, and they're rather wonderful. He also took the first art. He took the first crayons up into space because he used to draw in space too. So things are starting to change. The Americans are catching up. The space race is going full blast, but things were changing for the worse in one way. Sergei Korolev dies from a routine operation. 2 years later, Yuri Gagarin dies in a crash in a fighter jet. And there was other remarkable things that happened. The Venera Lander, this is the first lander ever sent from Earth to land on another planet. It lands on Venus, and it gave readings about the temperature and the conditions on Venus until the point it was burned up on the surface. And also, 2 lunar rovers are sent up remotely. And they drive around for a few kilometers, and they sent back thousands of images to Moscow. But the Americans are pushing ahead on their Apollo program. And after July 20th, 1969, when the moon landings began for the Americans, the Soviet Union gives up their lunar ambitions. So the Americans started a run of moon landings. It started with Apollo 11 and went on to Apollo 17, with the exception of 13. And they brought up lunar rovers. There was 3 lunar rovers brought up on the last 3 Apollo missions. And there's also the 2 Russian lunocoid vehicles up there. So the next time we go to the moon, there's 5 vehicles waiting for us to use. We just have to dust them off and turn the ignition key and we can go. So can you believe it's been 45 years and 5 months since we went to the moon? 45 years and 5 months. Just ridiculous. So NASA's emphasis after this program switches to the reusable space shuttle. Meanwhile, the Soviet Union turns to space stations, and the first space station they put up is the Salu. Now, this expertise becomes really important. The Salu is launched from Baikonur in April 1971, and it's the world's first crewed space station. And it pushes all kinds of boundaries of human spaceflight, living in orbit, how to transfer one crew to the other. It set records for scientific experiments. New technologies were discovered and created. And it's replaced by here's the space shuttle, and the Salu is replaced by the Mir. Now the Mir is the first spacecraft that's built in a space station in a modular way. So different modules are launched one after another and put together. Now Mir becomes quite a legend, and it stays in orbit for 15 years. It's launched in 1986 and is up there. Its solar arrays provide power for the cosmonauts, and then the astronauts, American astronauts, and cosmonauts from different countries stay up and visit Mir. More than 20,000 scientific experiments are run on Mir. It's a real child of the Cold War, Mir. And at one of the last cosmonauts to go up was Sergei Korolev. Now, when he lands on Mir, he's a citizen of the Soviet Union, and while he's up there, the Soviet Union ceases to exist, and he comes back down and he doesn't have the right passport when he lands. They let him in anyway, don't worry. But Sergei Korolev later became one of the first Russian cosmonauts to fly on the American space station. So that's a bit of a potted history. So that tells you where we are, to put it into context. So where are we now? Well, we're back in Baikonur. Why? Because Baikonur is the only place on the planet now for human space flight. Cape Canaveral no longer launches humans into space since the space shuttle finished in 2011. And not only is it the oldest cosmodrome, but it's the busiest. It's launching satellites, and one of its regular launches is the Progress spacecraft, which goes up and takes supplies to our friends up there at the International Space Station. And by the way, I have some exciting news for you, because the space station is overhead above Almaty for this week, because it goes in an elliptical orbit. So tonight, and you can find this online, tonight, here are the times you can look up and see it, and it comes from the west, and it's super bright, you can't miss it. At 8:45 tonight, and at 10:21, there's going to be 2 very, very bright crossings. So look up in the sky, 8:45 and 10:21, and it's overhead on Wednesday and Thursday night as well. So check it out. You can't miss it. So you might not have thought about how the International Space Station resupplies its inhabitants and gives them fresh food. And by the way, they send them cargo, and they send them fresh food and water sometimes. The favorite space food apparently are spicy shrimp cocktails. Don't know why, but that's what they always ask for. But the resupply of the space station has become just one example of the enormous space economy. that has taken over the world now. It's worth $355 billion every year, $355 billion every year. But the interesting part about that is that 78% of that $355 billion, 78% of that is generated by private companies and by corporations. So they are the ones making the running now. They're the ones that are changing the game. And it's growing. Just satellite technology alone will almost double over the next decade what it's worth. The main customers remain governments who are launching satellites, who are doing research, but the main enablers are the private sector. And there's not only the benefits of the technology that we are all using right now, but an economic benefit, the multiplier effect of any country that has investments, whether they're private or state, into the space sector. The multiplier effect in terms of creating jobs and income is about 5, in the factor of 5 in a developed economy. In a less developed economy, it is 7 to 8 times the investment. In other words, the tax alone that these space companies are paying governments more than pays for all the investment governments put into space. And satellite technology affects every aspect of our lives, as we've said before. Navigation, communications is one of our biggest ones. Meteorology, Earth observation, watching glaciers melt, watching deforestation, watching streams of refugees coming through, monitoring transportation, and allowing urban planning. Not to mention all the demands that we are making on it as journalists to transmit and broadcast our stories. Enable Skype interviews, do the research that we always do, and the mixed blessing of social media, unless you're Yusuf Omar, who I have been inspired by this morning. Yusuf, are you here? Well, can you please just go up to the International Space Station? Because you would do the coolest broadcast. They're broadcasting all the time up there, but you could show them a few things. So what this means, one of the consequences of all of these satellites that are up there, is the problem of space junk. Oh, he's not space junk. He's doing something really cool. Here's space junk. There are, since Sputnik launch in 1957, 41,000 things have been launched. 5% of them are still active. Now, most satellites and even space stations are enabled to have lower and lower orbits, and Earth and the ground control that each one of them has a control in them will bring them down into the Earth's atmosphere, and they'll deorbit and they'll burn up. But some of them have lost the ability to communicate with the ground, so they're still charging around up there. And this is a big, big problem, because there are literally tens of millions of bits of space junk in low Earth orbit, because bits fall off, bits crash. And they range from an astronaut's glove that got away on a spacewalk to all the defunct or broken satellites that I've mentioned. Now, it got a lot worse in 2007 when China deliberately exploded one of their weather satellites to test one of their new defense systems. And then in 2009, an American Iridium satellite crashed with a Russian Cosmos satellite, creating about 10,000 more bits of stuff flying around. And it's a big problem, because even a little fleck of paint can pierce an astronaut suit when they're on a spacewalk. A bit of debris the size of a tiny coin knocked into a European Space Agency satellite not long ago, and it hit one of the solar arrays, and it knocked the satellite out of alignment and damaged it. Because everything that's up there is going at about 28,000 miles an hour. That's 17,500 miles, 28,000 kilometers an hour, or 17,500 miles an hour. So that's pretty fast. You don't want to get hit by that stuff. So 23,000 objects. You wondered why there's a grapefruit up here. 23,000 objects up there are as big or much bigger than a grapefruit, are being tracked by NASA. And every time one of these comes at you, do you want this coming at you faster than a speeding bullet? No, is the answer. So some satellites have the ability to change their trajectory, and if NASA will give an alert, we know where everything is, and they'll move. But how do we get all this stuff down? There's various technology that's being used right now. There's a mission called Remove Debris that's just been launched. There's harpoons that are being tested. There's nets. If everything does crash like the collision that happened, and crash again, you have something called the Kessler effect. Now, if you saw the film Gravity, which is a terrific film, although it's not all correct scientifically, this is exactly what happened there. And here's Sandra Bullock looking at, well, supposed to be Sandra Bullock looking at the crash that's going to give her all sorts of adventures and lose her George Clooney's companionship. Sorry, spoiler alert. And by the way, there's an interesting fact. The Indian government launched a wonderful Mars probe about 5 years ago, and they did it absolutely on a budget, and it had produced some great science. The whole of the launch of the Indian Mars probe cost less than the production of Gravity, the film. You don't have to choose between them, you can have both. So there's a lot of things up there, and the largest fleet right now of satellites is run by a company called Planet. Check them out, planet.com. Now, they have 190 satellites orbiting the Earth, and they're orbiting from pole to pole, and they're tiny. They're actually probably about the size of this iPad. They're tiny little satellites, and they're photographing every single bit of the Earth. Over the course of the day, they produce 1.2 million images. Planet, 190 satellites, and so they will sell those images to just about anyone that can pay. And also, you can go on their website and get some free images. They'll give some of these free to NGOs and other humanitarian organizations. Governments use these to monitor borders, environmental observation, of course, but human rights campaigners have been using these satellite images. Companies use these satellite images to count the number of oil tanks of their rivals or competing countries. The resolution of these satellites can even show large trees. So this raises a whole series of really interesting questions about, there's enormous geostrategic implications from these, and of course the ones about privacy as well. So Planet, very interesting, but it's just one of the many corporate companies that are creating technologies that are changing our lives forever, the disruptors. And one of the big ones that makes a lot of noise and has a lot of publicity for itself is SpaceX. Now, SpaceX has just launched Tintin-1 and Tintin-2. These are two satellites named after Tintin, who of course explored the moon with his dog Snowy, who has a wonderful little spacesuit there, which Lika should have had. It would have saved her life. But Tintin-1 and Tintin-2 are part of a fleet of what Elon Musk says he wants to have of 11,000 satellites to provide the cheapest broadband in the world by 2024. Google's a major backer of this, so keep your eye on, it's called Starlink. It's a system called Starlink. So Elon Musk is an inspired genius behind SpaceX, and he is changing the game. Since 2012, one of his rockets, one of his spacecraft, the Dragon, has a contract to resupply the International Space Station. Quite a few do, but Dragon was the first private one, and it goes up. It goes up at regular intervals. Now, Musk, among his modest ambitions, is to colonize Mars. Musk says he wants to die on Mars, but not on impact. So now SpaceX owns the world's biggest and most powerful launcher, the Falcon Heavy. Now, any Star Wars fans in here? Yes, of course, the Falcon, of course, is named after the Millennium Falcon that Han Solo flew. So there's also a lot of whimsy in the names that Elon Musk chooses. Oh, here we go. Well, I think that was a remarkable achievement. Now, despite the power of the Falcon Heavy, you need an even larger rocket if you want to go to the moon, if you want to go to the Mars, because you have to go beyond low Earth orbit. You have to reach escape velocity. So this is an artist's impression of the one that they're working on now, called the BFR, and it's Big Falcon rocket, but it's not Big Falcon rocket. The real name of it is the Big Effing rocket, according to Elon Musk. But there you are. Now, Musk's great rival is just Jeff Bezos. Now, Jeff Bezos, who made his fortune through a little thing called Amazon.com, has designed, his company is called Blue Origin. Now, Blue Origin has also perfected the technology for landing the rocket booster back on its tail. But he doesn't make as much noise as Musk. His company's motto is Gradatim Ferocitur, which is Latin for step by step ferociously. And his company mascot is, or motto, shows the turtle on it. So what he wants to do, while Musk wants to colonize Mars, Bezos wants to save the Earth. And he wants to save the Earth by moving manufacturing off the Earth. He wants to move manufacturing to the moon. He wants to move the manufacturing to asteroids. He thinks that's the only way we're going to be able to carry on this planet. So, okay, why does this work? Why do SpaceX and Blue Origin work? Well, and Planet. They not only the technologies they perfected have reduced costs. I mean, it comes down to actual money. The booster, every time a rocket has been launched, up until SpaceX and Blue Origin, every time a rocket is launched, the booster drops back down and either is destroyed or not used again. The booster has the engines in it, the booster has the fuel in it. The booster is 70% the cost of any launch is in the booster. So it's sort of like flying on a 747, a round trip between London and Almaty, and chucking out the plane and just throwing it away afterwards. So they decided they can't happen any longer. And that's why they perfected the return of the booster landing on its tail, as you saw. So what's it mean? Okay. If you want to send a kilo of anything into space, whether it's a satellite or whether it is a cosmonaut, to send a kilo of anything on SpaceX, and I think the prices are about the same for Blue Origin, is approximately $5,000 a kilo. $5,000 a kilo. Now, During the time of the Apollo program, when Americans went to the moon, the cost for a kilo was $46,000. During the time of the space shuttle, many satellites were launched off the space shuttle, the cost of a kilo was $60,000. So why does it work? Because it's reduced the cost of getting anything into space by 90%. That's pretty substantial. So where are we going to go next? Well, the plans for return to the moon are well in advance. Last year, the year before last, Roscosmos announced that they're going to start sending lunar probes and then a lander back to the moon ahead of cosmonauts going to the moon in the 2030s. The Americans have just tested a new capsule called here we are, so we know what we're talking about. A capsule called the Orion, which is a larger, better version of the Apollo capsule, which can take six people. So the moon may be the base that we need in order to go on to other planets like Mars. The moon also can be used to do a lot of research in the same way we have research stations in the South Pole, research on human health in space, a research about what minerals we can get. There is water on the moon, we now know that. There's rare earth elements on the moon. There's even rarer material on asteroids. Some asteroids, it's reckoned, could be worth $30 billion in terms of what you can mine from them. Then there is Mars. Now, David Bowie asked, is there life on Mars? Well, there might have been life on Mars, not life like we have in this room, but other kinds of life. There's so many elements of Mars that are sculpted by water. There's a canyon there which is 10 times the length of the Grand Canyon on Earth, 4 times the width. There's areas that are riverbeds, old riverbeds that are dry. There's all sorts of very interesting things. So things have been happening there. At one point there was, before the atmosphere got swept away. And there's a whole new series of challenges on Mars. There is the challenge of, well, the first challenge is actually how to land there, because it's really hard to land when there is an atmosphere. And most of the craft that have been sent to Mars actually crashed. But new successful technologies are now being used, and this is one that I particularly like. This is the Mars Curiosity, and this is how it landed. So it comes off the spacecraft. The parachute is of limited value because you have very little atmosphere there, and it's carrying all this very delicate scientific equipment. So you have this system called the Sky Crane, and the Sky Crane is now firing off retro rockets to soften its landing, and protecting, and it's protected until it dropped the heat shield. It's protected this extraordinary bit of equipment, which also includes diggers, which can analyze the material it finds on Mars. Here it is about to touch down on the surface. The Mars Curiosity landed in, when was it, 4 years ago now. Here we are almost ready to touch down. But then, of course, you have the problem of the Sky Crane above it. And you'll see how that one was solved. The wheels are now deployed. Curiosity is touched down. Curiosity is the size of a medium-sized car. The Sky Crane shoots off in the other direction, leaving Curiosity there. Now, I would really urge you, go on to the NASA website. Every single day, Curiosity posts another photograph. And it also does selfies. So here's a selfie that Curiosity did. So it's remarkable, and Curiosity is still working and providing us with incredible data all the time about the geology of Mars. So when we go to Mars, How do we have enough fuel to get there? How do you have enough water to get there? But the bigger problems in getting to Mars, which at its shortest point takes about 7 months, are human health. Because we're built to live on this gravity. Mars has about a third as much gravity as the Earth. It has what we call microgravity. But when you're in outer space on the International Space Station or on Elon Musk's soon-to-be Mars mission, you're going to be living without any gravity for not just 7 months one way, but the time you spend on Mars and 7 months on the way back. So this causes all sorts of problems. Your muscles are atrophy, even though you're doing exercise, and our heart is a muscle, so that's not good news. You have increased cranial pressure, which means that it affects your eyesight. Every single cosmonaut and astronaut that's come off of 6 months of the International Space Station has had a reduced sight. So are you going to land on Mars and be virtually blind is a question. And also you have the problem of radiation, which is protected. We're protected from radiation by our atmosphere. So if you walk around next to the Curiosity here, you're going to get zapped by 250 times the amount of radiation that we have here on Earth. It's not healthy, and there's all kinds of challenges. So anyway, where else is there life? Could there be life in the solar system? Well, the moons of Jupiter and Saturn are where also we're looking. This is an artist's impression of a moon of Jupiter, where you're also going to get a nice view of Saturn. This is Titan, where we know there's rain, methane rain, and storms like on Earth. But and there seems to be some organic matter, but it's also 150 degrees minus centigrade, so probably not very promising. Europa, another moon, has a better chance. It has liquid water underneath a layer of ice and energy sources which are useful, and also you have amino acids which formed organic compounds at the beginning of what created us on Earth. But probably the best bet is a moon of Saturn called Enceladus. Now, Enceladus is a wonderful and rather beautiful moon, and it has these 4 stripes here on the left. They're called the Tiger Stripes. And over the last few years, the Cassini mission, which ended last September, flew increasingly closer and closer to Enceladus, and it could sniff things and analyze things and send it back. And coming out of Enceladus, they discovered these fumes, which turn out to be water vapor. And the water vapor, again, had organic compounds in it. So we think underneath this icy surface, there is an ocean, and the water underneath it could approach boiling point. So, anyway, that's a view. Are there aliens out there? I have to mention this briefly because everybody loves aliens. Well, Frank Drake came up with this equation about working out civilizations, whether there were any civilizations out there. And I'm not even going to begin to read this, but you can Google Drake equation. And the answer is about 1 in every 10 million stars might have exoplanets around them, small planets like the one we're on right now that orbits another star called the Sun. But the problem is that we are in the rural part of the Milky Way galaxy. That's the center of the Milky Way galaxy. We're way out there. We're like sort of undiscovered Indians in the Amazon, off on the Amazon tributary, and we're too far away to talk to anyone. So maybe that's why we haven't found them yet. But if anybody does, please let us know, and I hope you do some stories on it. There's a lot of stars out there, and most of them have planets around it, just like the ones that are in our solar system. That's 300 with 36, 30 with 36 zeros behind it. So a lot. And exoplanets could have life, they could have not. Many of them are far too far away from us. Unless you get into the realms of science fiction and you talk about things like wormholes, to go faster than the speed of light to get to. But we know about a lot of this because of the Hubble Space Telescope, which is going to be replaced in the next few years by the James Webb Telescope, which is going to literally be able to see back in time. The Hubble has told us so much about the planet. It's told us about, it's taken pictures of star formation in the Crab Nebula, the pillars of creation. These are actually dust, stardust with planets and stars forming. The Horsehead Nebula. Remarkable images. It's increased our knowledge of quasars, black holes, all sorts of wonderful things. The James Webb will give us even more. It's being launched in 2020. This is what it will look like. It's going to be it's an enormous array. It's an infrared telescope, and it will be able to tell us a lot about things like black holes. So, if there are aliens, I'll leave you. We're wrapping up now. I hope you're relieved to know that the United Nations will be able to speak to them, because this is for real. This is the United Nations, I got to get the name right here. This is the UN agency that has been created to talk to aliens and other space things. It's the UN Office for Outer Space Affairs, based in Vienna. So if any aliens contact you on social media, tell them to get in touch there first. That is a designated speaker to aliens. And that will be an interesting thing to happen when it does, because the UN has interesting ways of communicating. So if aliens do arrive, they probably will have come through a wormhole, which is a way of connecting 2 points in space, and it is actually mathematically probable. But where does this mean? What does this mean to the media? What does this mean to the media, bringing back to how we cover these stories? Well, journalism drove. Journalism taking images like this one, Earthrise, which was photographed by Apollo 8 when it orbited the moon in 1968. Now, Earthrise was the beginning of the international environmental movement, and it was driven entirely. It was driven by journalism, and it was driven by this image that we have of our fragile planet, and many of the people that have seen this remarkable sight have devoted their lives. Cosmonauts and astronauts have devoted their life after they've been in space to protecting our incredibly beautiful and remarkably fragile planet. In fact, it's led to it's a thing called the overview effect. And it started with Yuri Gagarin. And he said, "When I orbited the Earth in a spacecraft, I saw for the first time how beautiful our planet is. Let us preserve and increase its beauty and not destroy it." And every space traveler since has echoed his word. So back to Baikonur. That's where the advances are going to be coming from, too. They're going to be replacing and updating the spacecraft. They're going to be sending more communication satellite. Baikonur and the new space entrepreneurs. Let me end finally with this image. You see that little dot in the red streak? Okay, that's taken by the Voyager spacecraft as it was leaving our solar system and heading out into interstellar space. They turned around its cameras and took a picture, and that's Earth. And I'll quote Carl Sagan. He said, "Look at that dot. That's here. That's us, that's home. Everyone you love, everyone you know, everyone you ever heard of, every human being who ever lived out their life on that speck of dust suspended in a sunbeam." So I hope you agree that what's happening in space is both inspiring our dreams, inspiring and fueling our dreams of wonder and our hopes for the future. And I think it's going to give us many, many more exciting stories for us to be able to tell. Thank you very much.
Excuse me. Can I have one question for you?
Yes. Where are you? Oh, right there.
Yeah,
yes, sir.
here.
Yes, sir.
So hard, honestly. Why program Apollo stopped 1971 or 2? Tell, please.
Why did the moon program stop?
Yeah, moon program, of course.
Oh, well, that's very close to my heart, too. The moon program stopped because if you have a race and you say that the goal is the finishing line here, and the Americans said that the finishing line was the moon, and once the Americans reached the moon, psychologically, they had reached the finishing point. But also, remarkably, the American, and they felt, oh, we've beaten the Soviet Union, but remarkably and depressingly, the American people became disinterested because there was going to be several more missions. And in fact, the last 3 Apollo missions, the last one was Apollo 17, which was in December 1965.
Yeah, I know.
And the last 3 were canceled because of lack of public interest, which
Why?
meant lack of funds. Lack of public interest, lack of imagination, lack of wonder, lack of so many things. I think it's just remarkable. And I've had so many people say to me, why are we going back to the moon? We've been there already. Well, that's sort of like Columbus landing in the New World, and he went a couple of times, and they went, we don't have to go back there. We've been there. Yeah, there's just a bunch of islands. That's it. Don't bother. We've been to 5 places on the moon, 6 places on the moon. They were all very close. So, yes, I don't know. I mean, I'm continually amazed that the Americans stopped going to the moon. But now the Chinese will be there, the Russians will be there, a lot of people will go there. They've realized the value of it. But I don't know the answer to that. It happened. And it's very sad that it did. Any other questions?
Maybe aliens problem.
Sorry, do you have?
Problem is aliens, maybe.
Yeah. Aliens.
Who lives there in the moon?
Aliens. Aliens. Oh no. I knew there would be
Okay,
questions about
thank you.
aliens. Yes. No. I would welcome them here. Let's say come and visit. No, I am afraid so far in this solar system we don't think there's any aliens more than microscopic ones, some maybe Earth some compounds, life-forming compounds that may be particularly on those moons of Saturn and Jupiter. But no, I don't think they're going to be any more exciting than that until they come through the wormhole and greet us. Sir.
But if you know astronaut Shubart,
Yes.
yeah, he told, I have one secret about moon. I saw something there.
Well, I don't
11
think
astronauts
Alan
were in moon, if you know, yeah. And everybody from that team don't tell journalists and no, don't interview about moon.
Well,
why? Tell me. Why? In your opinion.
Well, I don't think there's anything on I think that we know a lot about the moon. We don't know everything about the moon, but aliens are not part of it. And there was so much live broadcasting from the moon and all those. I mean, governments are not good at cover-ups, as you know. So I don't think that, and I don't think that anyone's holding back information on aliens. Any other questions?
I have a question. May I
Please.
Russian?
Yes. Oh, sorry.
It's for you.
Thank you.
Да, у меня первый вопрос про...
What do you think about Vladimir Putin's plan to build a cosmodrome in Russia, in Siberia? And what do you think will then happen to Baikonur? And the second question is, how high is the probability of fake photographs off of Mars, considering that such photographs can be made in Photoshop?
Okay, what do I think about the plans for the Russian to build their own cosmodrome? Well, that's normal. At the moment, the Russian Federation has leased Baikonur for 50 years, and of course they want their own. Everybody wants their own launch facility, but it won't have the advantages of Baikonur because it won't be as far south. The way that, because the Earth rotates, the rotation of the Earth is faster at the equator than at the poles. So when you launch a rocket, you want that extra bit of kick that you get from launching on the equator. I'm sure they'll build a perfectly good cosmodrome, but Baikonur is still the biggest in the world. It still has tremendous facilities. And it has the potential to be opened up to all of these different private companies that are launching, because they're having to build their own launches. And in fact, another private launch happened yesterday morning from America. It's the Antares space cargo launch that is on its way up to the International Space Station. It's doing a number of orbits around the Earth for other reasons before it will dock with them, I think, on Thursday or Friday and deliver their spicy shrimp cocktails along with cargo and other science experiments. But Baikonur could be opened up for private use. I mean, it's a tremendously rich possibility, and it was a tremendously profit-making possibility. Sorry, you asked me one more thing about fake news. Well, fake news, and again, we've heard this morning in that wonderful presentation about, I think we talked about fake news there and how you can, of course, you can mock up images. I mean, you can mock up images of Zuma's son getting arrested. It isn't that much harder to mock up an image of creatures running around the planet on the face of Mars. But I don't think that's going to happen, and you can easily work out whether they're accurate or not. We know enough science about all the different planets on the solar system and much more for fakes to be able to be told. Right.
My question is like this. In the modern world, the more we move forward, the more we have to monetize journalism. In your vision, future of science publications, science journalism, how do we monetize there? We've lost a lot in the past few decades when it comes to that, because before there was tremendous interest to science journalism, but in today's world, unfortunately, when everyone's getting used to quick news, brief bites, sound bites and pieces, we're somewhat moving away from these interesting themes of science, and that makes me concerned. That makes me concerned about new generations.
To do the research and the background that good science journalism takes. I agree, and I think that's and again, I think it's a continuing problem. It's a continuing issue in journalism, because there are certain subjects you do need to have the background to interpret, and that's why I wanted to give a little bit of context in what I was talking about. You need the background to be able to understand how significant something is or how non-significant something is and where it will lead to. I think that journalists have got to continue to be really good at chemistry or biology or physics or astrophysics or cosmology or medicine. If they're covering those subjects, you have to have some sort of in-depth, you have to not only have good communication skills, but you have to be able to have the specialist knowledge to be able to put them into context and explain something simply. And in fact, with some of my colleagues, we were talking about this last night. Now, one of my heroes is Richard Feynman, who got a Nobel Prize for physics. And he did these astonishing things. But he also said, unless I can explain my experiments to this man walking down the street, it shows that I don't understand it. But you have to understand it really properly before you can simplify it. I am worried about it as you are. And another question? Yes, sir? No?
The space had always been a monopoly of governments, and now private business is going to that. What's ahead? Will it become just sightseeing for common people in the future?
78% of the space industry is now driven by private and corporate money. But that money is going up to launch scientific satellites and navigation satellites, as well as human space flight. So I don't think that it will become sightseeing for tourists. It's too expensive. There are other companies like, which I didn't mention, Richard Branson, Virgin Galactic, who is going to do suborbital flights for people to look down on the planet. If I could afford it, I would do that. Isn't cheap. Elon Musk is talking about doing suborbital flights so that you can go from one side of the globe to the other in less than 2 hours. Considering the quality of airline food nowadays, I would love that. It would keep me from having to eat that and sit on planes for long periods. So yes, but those are all going to be tiny amount of people that ever can afford to do that. The money is in satellite technology, and how we use that is the future of spaceflight, as well as the science, as well as learning more about our solar system. Because every time we learn about our solar system, we learn more about ourselves. All the work that we did on the moon, and there's 346 kilos of moon rocks that were brought back. Those moon rocks, they kept 2/3 of them sealed and vacuum packed, because they knew that over the years the scientific instruments would become better and better. And so every year they bring out another kilo or two. And scientists who have proposed experiments with this are discovering more things about the origin of the Earth by studying the moon with better and better instrumentation. So the more we learn about the solar system, the more we learn about our planet. And to me, the ultimate thing would be for us to value our own planet to the point that we actually look after it properly. And maybe if we know more about the galaxy and the universe we live in, maybe that will happen. So that's my hope. And I think on that I'll end. So thank you very much.